Welcome back. Final panel of the technical track. PKI and certificates, navigating internal and external trust. We have Tim Hollebeek, Vice President of Industry Standards at DigiCert, Dr. Taher Elgamal, cryptographer, entrepreneur, and father of SSL and partner at Evolution Equity Partners, and Dr. Jim Goodman, CTO and co-founder, Crypto4A.
Hi, I'm Tim Hollebeek. Welcome to our session on PKI and certificates, navigating internal and external trust. Our first question is to Jim Goodman. What are the key differences between pure and hybrid certificates, and how are standards bodies currently shaping the definition of and interoperability requirements?
Yeah, thank you very much, Tim. So typically, when we think of a pure certificate, it's something that has a single signature element within it. And that signature, though, might actually consist of multiple signatures, and the notion of a composite signature, or it might be something just a single algorithm. So you might just have an ML-DSA signature within that certificate. Or, for example, you might have hybrid composite where you have an ML-DSA compared with a classic solution. So you might have RSA paired with it as well. Whereas a hybrid certificate is something that typically has multiple signatures embedded within it. And they're typically encoded in a way that would allow you to have a legacy verifier or previous old school one be able to parse that certificate and apply it. So that's probably the biggest difference between the two, is that in a hybrid configuration, typically you can pass that into a legacy verifier and it still can be processed. Whereas with a composite or a pure scheme, the verifier has to know the algorithms that are being asked for and has to be able to process. It's typically the main difference there.
All right, Taher, any comments?
Well, yeah, I mean, there's different use cases, because in one case, you want the customer to double duty, to use both algorithms just in case they don't trust one or the other. In the other case, you want to give the customer the choice of which algorithm to actually use to verify the thing. So they have slightly different things. I just want standards, that's all.
Absolutely. Yeah, standards are very important. Otherwise, you don't know what you're doing. And of course, in this world, you're always interoperating with somebody else on the other end of the line. So you have to make sure that they're doing everything the same way you are. Otherwise, it just doesn't work. So you mentioned use cases. Are there any specific use case or deployment model considerations that people should be aware of?
Well, it depends on the business itself. So if the business is a service provider, they actually do have to accommodate probably all of them. So whatever gets standardized, they probably do need to accommodate many things, because that's how the world is. If they're implementing things for internal purposes, then the migration from the existing algorithms to the PQC becomes the main thing. But if you're a service provider, you're going to maintain the two for a long time to come, because you have to support your customers regardless of what they do, right?
Absolutely.
So it depends on what the business is and what people care about.
Yeah. And of course, you're very familiar with TLS and SSL. That's a very different use case from many of the other uses of asymmetric cryptography, right?
So that's right. So code signing is very different, because it's an internally driven thing. So people can go now and actually start to PQC code signing, because they sign and they verify. So it's much easier to deploy. TLS is the trickiest one, because you're sitting in the middle of the digital society and you want to be basically interoperable with everybody.
Absolutely. And of course, TLS is the one that gets hit in two different ways. Would you like to explain both uses of asymmetric cryptography in TLS?
Well, maybe two, maybe more. Depends on what you look at. So the key exchange is kind of the first thing. Is that when we designed TLS from the beginning, we wanted a key on both sides that the client and the server can talk to each other and they can trust the key, and the key gets to encrypt. But to verify that you're talking to the right party, you need to sign something, where the digital certificates come in. So there is a signature and there is a key exchange as well.
Absolutely. Jim Goodman, any comments on that?
Taher raised a really good point about the different use cases in terms of the internal versus external. And actually, this is something we deal with all the time. The early adopters are really using PQC at the moment predominantly for doing firmware signing and code signing and secure boot mechanisms, which, as Taher pointed out, are all proprietary mechanisms, which allows you to go with like a pure certificate that basically has a specific PQC algorithm, because the devices that you're using with have been tailor-built to do those kinds of things. You don't have to worry about that compatibility problem. But as Taher pointed out, when you get into the Wild West and the real world, you have to be concerned about whether or not someone can basically consume that certificate and verify that chain. So,
absolutely, and standards are very important for hardware security modules, because of the fact that updating them is a little bit of a challenge, and you kind of need to know what you're doing.
Well, and one of the things we have to be wary of too is if we go to make changes, we have to go through the FIPS certification process as well. So we have this massive tail that we have to 12 to 18 months to wait to come out the other side to be used in an approved kind of system. So yeah, it's very important to us, which is why we're seeing the IETF work so hard to try and get the standards out now. There's a huge effort underway to get that done.
Yeah, I'm glad you mentioned IETF. There's a lot of really fascinating things going on there right now, and getting it right and getting it out are sometimes conflicting goals and difficult for everybody involved. So it's very interesting to watch. So as we're moving towards quantum resistant certificates, how will they impact internal PKIs, which are very common at large enterprises, particularly the trust hierarchies and certificate profiles? Let's start with you, Taher.
I mean, honestly, I look at this as an opportunity for people to relook what they've done. Because if you see the internal PKIs today, there's a lot of different things. And every customer of size, you're going to see multiple things that got done at different points in time. Some of them they acquired from a third party. Some of them they did themselves. And they're supposed to all talk to each other and that kind of thing. So it's actually, to me, it's an opportunity to revisit how are we authenticating all the different internal services, devices, and people to each other, so that the whole operation is more seamless. I actually like the PQC phenomenon because it's probably the best change agent this industry has seen.
Yeah, this industry has not seen a lot of change recently, and it's about to see a lot more.
And we built it on standards from day one.
Yeah.
We took it to IETF because we wanted it to be a standard. It's going to get a little, complex, but at the same time, we can use it to actually simplify things. So I think at the end, we'll be in a much better world.
Absolutely. We've learned a lot since we started doing this a long time ago.
We have.
So absolutely.
Yes, we have.
Jim Goodman, any comments on that?
No, once again, as expected, Taher has an outstanding answer. The notion that we need to do this right, and this whole transition thing we're doing, we're developing systems that are better at evolving, right? So we're using this as an opportunity to basically develop much more robust and resilient systems, which in the future, as we try to transition to different things or as we evolve, they're going to be capable of doing that, which is great, right? The days of having a single algorithm that we relied on for decades, like RSA and ECC, they're probably gone, right? We have to be very agile and adapt and be able to, right now we're going to use ML-DSA, but perhaps that'll change over time. We're putting in the infrastructure now and thinking about the things and defining the standards that are going to let us do that. In addition, this whole kind of transition is also motivating the notion people are going in and examining what they've got, what they need to do, as well as what they can change. And it's a great excuse to go and replace infrastructure with new devices that are much more capable and adaptable. So it's a fantastic opportunity, once in a career kind of opportunity, to be honest, as far as I'm concerned.
Oh,
the
absolutely.
agility thing that Jim mentioned is actually very interesting.
Yes.
Because we have to plan for change.
Yes.
Things are not going to be fixed anymore. When you actually go and see what people have now, they do not know what they have to begin with.
Yes.
So it's an opportunity to just revisit this entire part of the industry. We're trusting each other based on this, infrastructure and technology, and people actually do not know what exactly they have and where.
Yes.
So it will actually get all of us in a place where, we're running things right. And the agility thing, again, is probably the way to move forward. It will change again, guaranteed.
Absolutely. And not just certificate, not just algorithm type agility.
No.
People are thinking about how you're restructuring your entire PKI and things like that,
Exactly.
and whether you will have both algorithms interoperating with one PKI or whether you'll have two separate PKIs that you're transitioning between. I always tell people that the important thing here is the transition. The algorithms are quite secondary, as interesting as they are mathematically. Jim, we mentioned crypto agility is not just about algorithms, but also about hierarchies and things like that. What are you seeing as far as enterprises thinking about their transition strategy and how they're going to transition between these algorithms?
Yeah, so we're seeing people do a lot of different things. And one of the things that is kind of interesting to me is just the days of having the kind of homogeneous kind of certificate chains where we basically, we started RSA and we RSA all the way down. We're starting to see people considering heterogeneous kinds of chains, which is kind of interesting to us. There's no reason it has to be homogeneous. So the notion that people are starting to look at these chains and think about the right way to do it. Do we have a really conservative root and then we put something more aggressive kind of down in the intermediate as well as the leaf nodes? It's leading to some interesting design decisions for sure. And as an HSM vendor, it's leading to some interesting challenges on our part as we try to support this range of algorithms we need to be able to certify and the likes. In addition, we're also seeing people consider what is the right transition path in terms of, do I stand up 2 parallel PKIs such that I can maintain my existing legacy PKI while I'm bringing this new PQC PKI, or do I do some kind of hybrid structure? So it's leading to a lot of really interesting structures and a lot of interesting techniques. And as we've been saying, it's leading to a lot of people kind of looking at what they have, taking inventory of it, and trying to design the best way forward, which is kind of nice, because we're taking the time to try and do it right, as you said, both on the standardization front as well as the implementation side of it.
Yeah, and I think, if we could convince everybody that, hey, next year we're just going to shut down the internet for a year and fix everything and upgrade it, that would be pretty easy, because the end state and the starting state are pretty simple. But of course, people aren't going to really tolerate us shutting down the internet for a year. So we have to have this operating correctly with both algorithms in the middle while the transition happens. And I think that's actually going to be the biggest challenge for organizations.
It is going to be a challenge, and there's going to be better use cases for all of these different things that Jim talks about. But it's not trivial, because this is not the topic that most organizations think about. But there are use cases where you want the 2 separate hierarchies, because you just want one or the other, because you're dependent on the other side, what they're talking. And if you want very high security, maybe you want the joint one, because you want all the different signatures to check. Mm-hmm. And with time, people will figure that out.
Absolutely. So, Jim, how should organizations think about phasing these changes in so that their business continues to run without disruption as they're experimenting with these new algorithms and even transitioning between entire hierarchies?
Yeah, I think they really need to evaluate what it is they're trying to accomplish and what services they're trying to provide, and just how much disruption they can tolerate, essentially, right, at the end of the day. Because if you're trying to provide a PKI, it's the root of trust, essentially. You can't just lose that, right? But at the same time, your risk exposure as quantum computers come online, and perhaps there's a cryptanalytic attack that might show up, perhaps. But they really do need to sit down. They need to think about what this means and actually seriously take a look at their resources, as well as take a look at what they're capable of doing in the time frame they're capable of doing it in. At the end of the day, like Taher said, we have to continue operating. We can't just stop things, right? Things have to continue to go on. So that's going to be a very tricky thing. And as you guys identified, that transition is going to be difficult. So maybe we start thinking about how we manage those disruptions, right? How to do that in the most efficient manner possible. So it's going to take a lot of work and a lot of organization, a lot of prioritization on the company sides of things.
Absolutely. And another elephant in the room that we haven't really mentioned is a lot of TLS and SSL is involved in browsers, and there are rules from the CA Browser Forum as addition to the IETF. Mm-hmm. And so, for example, if you want to use ML-DSA with a web browser today, you can't, because the CA Browser Forum hasn't updated the requirements to allow ML-DSA yet. So organizations are going to have to deal with the intersection of both of those requirements, and especially with things like web services, which are often running on the same servers as their public web services. It becomes difficult to sort of keep track of what you're allowed to do in public and what you're allowed to do in private. And so any thoughts about what speed we think the browsers are going to move at, and how are organizations going to manage the fact that certificates are going to be very different in the public browser space than they are probably in the private space going forward?
Yeah, this is the catch-22 game here, because I think the majority of organizations and people believe the quantum threat is actually coming. Mm-hmm. The catch-22 is who jumps in first. Yeah. So the browser companies are required to participate. Otherwise, where are you going to connect from? Mm-hmm. But they are not going to connect on their own, because the cloud service providers, although there's a lot of overlap, have to also participate, and the HSM providers, and and everything in the middle. So what comes first is something that the industry needs to actually orchestrate. It's not trivial. And then each entity will have to decide, talking about what Jim is talking about, how do you migrate is something that each entity will have to decide. Maybe somebody will do a few applications at a time. Maybe somebody will do a few data centers at a time. And there's not going to be a rule for everyone, because every business is actually different. So that combo, needs, I don't know which forum is actually going to help people, but I think we need sort of industry experts to help people to how to do this.
Absolutely. Jim, what are your thoughts on this transition?
Taher, as always, nailed it. I think the biggest thing there is going to be prioritizing things, right? And as you said, there's kind of this competition. Different people have different priorities. They're going to have to transition, but they're relying on infrastructure that maybe they share with other companies. And then how do you prioritize that infrastructure so that when I want to make that transition, I know the components I need are going to be there and that they're going to be working. I think to that end, the CA browser reform does slow things down because it's waiting for standards to come online that. But at some point, they kind of have a big hammer where they can force people to comply, right? They can kind of force that transition. But we're not sure when that's going to happen. On the private side, you do what you want to do when you want to do it, essentially, which is, I guess, kind of nice. But you do require, again, you need infrastructure and components that are going to be compatible and capable of doing what it is you want to do. So there's a great deal of work to be done, and there's a lot of moving pieces, as you guys are attesting to, right? Like it's this disruption is what, let's call it transition, not a disruption. This transition is going to take longer, and it's going to be more expensive than we expect, as in all things, it seems. So best to get started on it sooner rather than later.
Yeah, let's go a little bit deeper into that. What sort of disruptions do we expect when people are trying to operate in an environment that includes both on their side, some mixture of post-quantum and classical algorithms, and of course the people on the other side of the connection, you don't quite know what they have, but they're probably in the same sort of mixed state. How are organizations going to manage that challenge and figure out which of their counterparties have which capabilities?
Yeah, no, it's exactly a point to be concerned with, right? Like, both from the perspective of what can their verifiers handle, what can their networks handle, like we're going to get much larger bandwidth considerations, we're going to have much larger certificates, what's going to happen on that front? One of the things, too, is as we go forward, we're seeing things like we're trying to push down certificate lifetimes and the like we're making all these changes. And as a result, we're going to have to introduce all these new processes and develop new skill sets to be able to deal with all these things. Now you're going to also, what if you have parallel PKIs? Well, now I've got twice as many certificates flying around. Well, my team better be able to deal with twice as many certificates, and does that mean I'm going to introduce automation capabilities into my certificate lifetime management processes? Yep, probably. That's another skill set I'm going to have to teach my team. So there's just a great deal of upheaval and a lot of things to consider going forward to make this all work. Like, never mind the math. Like, as you said, it's not the algorithms, it's the processes that are really going to be the difficult part of this. So let's get on top of those as quickly as we can.
Yeah, I think it's very interesting that some of the PQC-related drafts in the LAMPS working group are directly related to the question of just how do you figure out which pair of certificates are actually related to each other, and how do you, if you've got a classical certificate, how do you find the post-quantum one, and vice versa, and especially how do you securely link them in with a digital signature when half of your digital signatures are about to expire and be untrustworthy, and who knows how many years. The transition's very, very difficult in that way, definitely. How can people sort of, how do they know when they're ready to move? And because there's so many things they have to be paying attention to.
So, personal opinion, tomorrow is when they're ready to move. But the move has to be designed and planned.
Yes.
This is not about panicking because some bad thing is coming our way. It's about planning. Because, the B2B applications, for example, will be easier to do because you can ask your partner which platforms, which applications, and you can actually make sure you're matching up and you can test if these are interoperable or not. The consumer things are going to be a little tricky because you can never actually tell a consumer you have to upgrade your browser to a new version. So the consumer stuff will actually take time. But the big value B2B applications should be tried first and a bit at a time. There's a lot of vendors in the middle. There is load balancers. People terminate these things at locations, and that's how they design their business. Some of them will probably want to re-architect things, but that will take longer. Most people, I think, would just want to, migrate from where they have to something that would be better from a quantum readiness standpoint first, and then over time get to where they want to get to.
All right, thank you both of us. That was a fascinating conversation. Any quick last words, Jim?
I think that the future is coming. I think that this will overall be a good thing because it's going to force us to raise our game and to be much more flexible and give systems that are much more resilient, that we're going to be able to evolve over time. So as you guys alluded to earlier, right now we're going to try and transition from a classic space into a classic plus post-quantum space. At some point, we're going to transition to a pure post-quantum space, but maybe it's post-quantum 1 with post-quantum 2. So the intent there is just the mechanisms and the pipes will all be there, and now we'll be able to just kind of evolve over time. And in the end, I think this is an outstanding opportunity, despite the pains we're going to go through to do it. I think it's an outstanding opportunity for us to re-examine things and do things right and make even better systems going forward, which will make whatever change happens in the future that much easier to do.
All right, and I'll give you the last word, Taher.
Oh, thank you. I always love that. You know, we have an opportunity now because the way this current infrastructure was designed was not meant to manage the current scale that we achieved over the last 30 years. So we do have an opportunity to actually make things better. But you know, let's plan things, not jump into things. So this is not about call your buddy and get a new library with you know, PQC algorithms implemented. This is about an internal set of projects that are actually well designed, that you know when you're going to deliver A, B, and C. And then at the end, you know you're going to be successful.
Absolutely. Thank you both. I hope you all enjoyed that conversation, and please continue listening.